Okay, so in this video, we are going to talk about how to determine relative extrema using our graphing calculator. So this is a software that we have at school that allows me to emulate what the graphing calculator will look like on your end. So I'm able to press the buttons on my screen and you're able to see and hopefully follow along with me at home or wherever you are. So what I'd recommend doing right now is getting out your calculator. This is the TI-84 Plus the edition, so realistically all that is different between this and any of the other section calculators is that this one has a lot more colors on the screen. However, you can do completely fine with any of the TI series. I recommend the TI series. That's what's most commonly used in education. However, if there are other brands out there that might save you a couple dollars, you can use those as well. However, I know a lot of your instructors are not usually as informed, and I know there's not as many videos out on the web on how to use these calculators. So I do recommend the Texas Instrument series calculator. However, you don't have to buy the $150 TI-84 Plus C edition. You can buy the regular TI-84 edition. You can buy any of the other calculators that are Texas Instrument, and they're usually very helpful. So now, if I want to find in this question, notice how the question says, using your graphing calculator, determine any relative max and min values of the function, and it gives the function right here. So the first thing that I want to do is that I want to plug that into my calculator. So over here, there's a y equals button. So on this side, it's going to have what my screen looks like on a larger side. For right now, I'm going to have my key history, so that way you can see what keys I depress on my calculator, and hopefully you can see on my screen here. And anytime we get anything important, I'll make sure to put the larger screen over here on my right. So right now, I'm going to type in my function. So I type 0.1, 0.1, 0.1, x, which I'm going to use right there. So this is the x button, x, t, theta, and n. But however, we're working in just an algebraic mode. So these are my modes. We are working in my algebraic, my functional mode, and then for most of the algebra classes, that's what you're going to be working in consistently. So make sure that you have these following portions highlighted on the mode. But most of the default calculators will have that. So again, so I have 0.1 x, and if you got a t, theta, or n, go back and look at the mode to make sure that you are in function mode. So we're identifying functions. So we're going to go back to the y equals 0.1 x, and I have to use my upwards caret, this up hat, and I'm going to raise it to the third power because I've raised to the third power. Then I have to actually shift right using mine. And then I'm going to subtract. Subtract is different than the negative sign. This is if we need to have a leading coefficient that is negative. For right now, the operation is going to be subtract. If you use this guy down here, if you use this guy, he looks slightly different, but you're also going to get a syntax error. So be very careful. We're going to have minus 0.6 x squared, so we automatically have a squared key here because we use it so often. We're going to minus or subtract 0.1 x, and then we add 2 at the end. So hopefully we can all plug that into our calculator. So now I'm going to hit graph, and notice on my graph it's going to default to a 10 by 10 view. So I'm going to change my large screen over here so we can see it as it graphs. Some may have a different view, and if you would have got maybe a smaller view or distorted view, I always recommend coming here over to the zoom key and pressing zoom 6, which stands for zoom standard. I like that one. That tends to be my go-to, and this helps to resolve the immediate dimensions of my calculator to be a 10 by 10 screen. Notice I'm just going to go ahead and make a mistake, and I'm going to change one of these values of a minus to a negative, and I'm going to hit this value instead. And notice if I try to hit graph now, it says, this is something going on, it's thinking, and I get something very, very different. Notice this would not be correct because this is 0.1 x cubed negative 0.6x squared. There's a syntax error here. This is supposed to be a minus. So be very, very careful that we have this input correctly. So now when I have this, I recognize that in my graph I have a max value here and a min value here. I have a max value up here and a min value over here. So if I want to determine the max value, I'm going to hit second, trace, which really stands for calculate. Hopefully you can see right above the trace button, you see CLC in blue, CALC in blue. So that stands for calculate. So I'm going to hit that now. and I get this option where it gives me a value, 0, min, max, intersect dy dx, and this funny little sign here stands for integral, but you're not going to do that in this course. But we're going to pay specifically attention to finding the max. So I'm going to scroll down to option 4 and hit enter. And notice it says determine a value to the left. Left bound means determine a value to the left of the max. So I'm going to come over here and hit enter somewhere to the left. It does not matter where I am as long as I do not surpass another max or min. So I hit enter. And then I'm going to come over here and determine a value to the right. It doesn't matter where I am, but I can't surpass another max or min, otherwise I might get the problem wrong. And I hit enter. And now it asks me if I want to guess, and I say, no, I just paid $100 for you. I'm definitely not going to guess, so I'm just going to bypass that. And notice it says guess, it says guess. I'm going to bypass that by hitting enter. And notice it gives me a max value at negative 0.081667 and a y value of 2.0041105. I'm going to go ahead and round the answer to the hundredths decimal place. So I'm going to say that I have a relative max at a point negative 0.08, comma 2.00. So this is going to be the coordinate point of the max. Notice it's blinking over here. This is the x coordinate and this is the y coordinate. So we always write our points in terms of x comma y. But this y coordinate is also usually known as the max value. So if the question asks for the max value, it wants the y portion of the vertex of the max. So be cognizant of that. Now, the question wants us to determine any minima. So it also says if there's a minima, we need to find the minima values. So I'm going to come over here and I'm going to find the minimum values. And I have to recognize they are around here somewhere. Hopefully we can see it around here. So now I'm going to go to second trace one more time, but I'm not going to hit max now. I'm going to scroll over here to 3, which gives me minimum. And I hit enter, and hopefully we saw a second trace, and I scroll down and I hit minimum. So I need to go to the left of the minimum. So I'm going to find approximately a value anywhere to the left of, so this is the minimum. I'm going to go somewhere to the left. I'm clearly to the left, but I don't surpass another max or min. So now I can hit enter. And now I'm going to scroll to the right. And it just says determine any value to the right of the min, and I recognize that's one of them, so I hit enter. So I do not want to guess. I'm just going to bypass this by hitting enter. And notice I get 4.08 and negative 1.60. So I'm going to have a relative min at 4.08 and negative 1.60. And this would be known as the min value. So that y coordinate is going to be part of the min value. If there were multiple maxes and mins, we could find them each independently, performing that same operation of going to second trace, and determining whether or not you are depending on whether or not you're determining a max or min, you would either hit option 3 or 4 and then continue. But in this circumstance, in this function, there are only two maxes, there are only two extreme values. What you're going to learn later on in the course is that the degree of the function, which in this circumstance is the 3, there's going to be 3 minus 1. There could be as many as 3 minus 1 or 2 maxes and mins. So I'm pretty sure at this point that there are only 2 extreme values. So that's all that I have. But if you needed to, you could have zoomed out to give a larger perspective of what's happening. So if I were to click zoom and go down here to option 3 and hit out and hit enter on this 3 option, it's going to say, hey, pick a value where I want to zoom out. I want to zoom out at approximately the origin. So I'm going to zoom out. I'm going to scroll over here using my mouse. I'm scrolling back. You could also just type 0. Oops, I could also trace. Let me go back here. So if I hit second zoom and if I just hit regular zoom, let me go back and do that one more time. So I'm on the graph. If I were to hit zoom and I were to click on the out key, I could trace and I could go back to 0. And if I want to zoom out here, I could click zoom and then I could go down here to option 3 and hit zoom out. And I could hit enter here and it would actually zoom out of a magnification of 10 by 10. So I could see a larger or a more grandiose perspective of the graph.